Myself, Dr.K.Arun Prasad. I am working as an associate professor in the Department of Mechanical Engineering, PS in College of Engineering Technology, Tirunelveli. Today's video we are going to discuss about the concept of computer graphics in computer aided design as well as in computer aided manufacturing. Computer aided design and computer aided manufacturing both are very important component for a mechanical engineers to produce as well as to make any of the design what they have wish to do as a form of product. So the graphics is nothing but a sketch or a drawing which represents a meaningful information. Actually, computer graphics we are seen in movies in the form of animations. So same thing in the mechanical engineering, we are having computer aided design software such as Pro E, now it is called as Creo Elements, SolidWorks, as well as for measuring the analysis system we have ANSYS, as well as we are having design and analysis system we have CATIA. So these are some of the commercially available, then AutoCAD predominantly we are known. So these softwares are commercially available for drawing purposes as well as for analysis to see the various in the application of the load, and finally after the application of the load we are going for the production of the component. This is the schema what is workouts in the industry to produce a product from the design of the diagram to the final product. So computer graphics is nothing but a set of images where we can place a set of images in the sequence of manner. From that set of images we are going to define what we are going to achieve. So graphics is nowadays we are prepared with the help of some of the gadgets like electronic camera, as well as we are having digital photography, as well as the very good example is our film entertainment. These are some of the technologies nowadays available to see higher level computer graphics as well as the real product in before manufacturing system. As well as this field of computer graphics is one of the very vast user interface, as well as user interface design, rendering, geometrical objects, animations, many more options are available for generation of any of the drawing to final product. Because nowadays we won't spend more amount of money or we won't spend more amount of time to produce a component, because we are following TPS production system, as well as we are following TPM, as well as we are adopting some of the principle of management concepts. All the managerial concepts are involving in a production system. So we are not in the position to spend more amount of time as well as more amount of repetition in the production area. So once we have that simple diagram or simple explanation about the product what we are going to produce, that is itself enough. With the help of that information we can start our production system. So nowadays the next level of our computer graphics is CG technology, computer graphics. So computer graphics where in the animation movies what we have seen, that is referred to computer graphics. So manipulation and representation of computer graphics is very simple workout where we simply place the images. From the help of that images we just simply manipulate the image from various graphical manner. From that graphical synthesis we can easily get the output. That is the simple logic behind the computer graphics. The placement of images in various places. From that various places we can get easily output. That output in the form of moving images. So computer graphics simply is moving image, and from that moving image we can see the reality. So types of computer graphics, the computer graphics is classified into two types. One is raster type as well as vector graphics. Raster type graphics is nothing but where we can fix the image in a pixel, and this image is called as a bitmap image, as well as this indicates large number of pixels together. A simple in a drawing we can simply put a horizontal vertical lines and create a box. In that box we can fix an image in that box. First I can fix the hair, then I can fix the head, then I can fix the eyes, then I can fix the nose, then lips, finally the complete face is came. So likewise the raster graphics have the similar process only, where we can fix the image in a box. That rectangular square box is called as pixels. In that square box we can fix the images, then we can render, then we can run that image, then finally we can get the movement of that final product, that is called raster graphics. Then vector graphics. Vector graphics is purely the fixation of these objects with the help of mathematical formulas. So these mathematical formulas are helps to draw the lines as well as shapes and various object defaultly present in the drawing softwares what we have used. So from this help of these softwares we can develop the image, and then we can with the help of the mathematical formula we can come out for the application. These raster graphics and vector graphics are nowadays familiar in all the areas. While we are taking the gaming application, the utilization of this vector graphics is very essential, as well as we can see in many areas of the high graphical games. As well as raster graphics is one of the method where we can see this raster with the formation of pixels in movies. Movies is the best example for raster graphic system, and the vector graphics one of the example is our high level graphics games. Then what are all the applications of these computer graphics? The computer graphics not only we use it in the manufacturing sector as well as in the filming sector. Other than that, we are having n number of applications are available where we can the utilization of MS Paint in our laptop is also a simple computer graphics. As well as presentation, we are using Microsoft presentation. We present something, some idea, or we can present some information to the student. This is also one example for computer graphics, because we are with the help of the software we can show some explanation, or we can show the concept to the students for the better understanding. So the main application of these computer graphic is to represent the concept lively, as well as we can represent all the form of outputs with live examples to the students or to the listeners, because the listener doesn't know or doesn't understand the concept clearly, but with the help of these computer graphics we can easily produce that lively enjoyment part for those peoples for the better understanding perspective, as well as for the education and training, for visualizing something, for example satellite photo, then stills what we can took from the camera. These all things are some of the applications area where we are using these computer graphics. So in the perspective of mechanical engineering, all the engineering departments as well as the professional courses, they are implementing these computer graphics for developing their views as well as for showing their ideas lively. Then now we are going to discuss about raster scan graphics coordinate system. Raster scan coordinate system is one of the rectangular pattern reconstruction system. It's a simple analogy where we can see this system earlier in a computer screen, as well as TV monitors, where we are having that big fluorescent tube. So that tube type of system as well as that type of monitors is called as raster scan graphic monitors. So in this raster scan graphic monitor we are having a horizontal line as well as a vertical line. These horizontal and vertical lines form a simple square dots. That dots is called as pixels. So where the images are passing in a form of wave, then this picture tube absorb that image, then it will present in a monitor. So now this is the complete working device of the raster architectural display. So this is a computer display where we are having a similar CPU. Then this display consists of one processor as well as a buffer frame, a video controller, memory system, then finally it moves to the monitor. So where this CPU receives the information from system bus, then system bus receives the information from input and output devices. Similarly, how the computer functions, the same setup it will have. Now the image only we can process here. So the input and output devices receive the image and it will transfer to the system bus. Then this system bus transfer the image to the display processor. Then display processor will send the image to the memory processor, because memory processor, once it absorbs the image, we can easily place the image wherever in the frame. That is one of the main application of the memory processor. Once we are having the images, we can multiple images we are having, we need to place the multiple images correctly in the frame. After the location of these images correctly in the frame, then we are move for the video controller. Then this video controller simply runs that image in the form of video. This is happens in the raster display. So this is advanced in earlier time, but nowadays we are having LED monitors, LCD monitors and LED monitors nowadays. So this is one of the older system of visualizing our graphics in a monitor. Then here we need to see some of the important components. Already we have discussed about the pixels. Then buffer is nothing but where is a memory. It holds the images what we currently work. Now simply I will pick an image. That image is stored in a buffer. Once the image is stored in a buffer memory, I can easily move the image somewhere else in the screen. Okay. This is the purpose of this buffer frame, where this buffer frame will helps to produce more intensity of the image, as well as this frame produces a very good illustration for the viewers, because this buffer frame, once the image is entered into the buffer frame, it allocates some memory for that image, because that image will help us in the time of framing the video. That image will produce very good impact on the time of viewing. So the raster scan system is purely an electron beam, how the flow of electrons moves through with the help of intensity of spot. That spot is called as pixels. So we can easily visualize that technology is called as CRT, cathode ray tube. What we can see in the earlier diagram, that explanation is simply shown here for studying the actually what happens. Okay, so with the help of this image, we can just simply I want to conclude all the what happens here in the architecture of raster display. Simply we have received the input image, then with that display process the image to the memory process, then buffer frame stores the temporary memory. Once the image settle in their place, then the video controller runs the image, then that image is visualized in a display. So this is the process how it will be worked out. Then some of the basic informations like the quality and other things depends upon the size of the monitor, as well as pixels what we chosen. Then if we want to save this video, we can have several format of saving that video, as well as if we want to save that picture, where here it is saved in the bitmap format. So these are the basic inputs where we need to learn while we are studying the concept of our raster display. Okay. Then next topic is database structure for computer graphics modeling. The main key role playing thing is this graphics modeling. So database structure for graphics modeling is a simple database management. How nowadays people are managing the data through cloud, but earlier days the utilization of cloud is very minimum. They can share the data through a sharing point. That sharing point is called a server, where with the help of the server they can keep all the information. With the help of the LAN they can transfer the data to the client system. So the client system receives the information from the servers. So this is called multi-database management, where we are building a very good database storage for the users as well as for the persons who are working in that area. So the database structure for a graphics modeling, where they are in the earlier days they are using our hard disk, as well as they are having this type of server type of system to transfer and as well as manage the data. So the modeling environment here, once we are moved to the modeling environment, this is a three-dimensional work. Actually we can see three-dimensional areas of the image, as well as three-dimensional graphics tendencies for a very topical and design properties. This is the modeling levels where we are going to arrange the images. First we can arrange the image in 2D, then we can extend the dimension up to 3D. That is the technologies available for this roster computer graphics, but nowadays the technology is developed to n. So how we can, based on that need, we can develop the images, as well as we can place the images and we can see the output. So this is incremental modeling levels, where we are using a precise composite images with various dimensions is also used, as well as in this technology we can extend up to 3D. So this is the data storage arrangement of our graphical modeling, where you can see the employee, then customer, product, then vendor, sales transaction. This is a simple flow chart. Then here how the management get that order, the orders they are received through order line, then customer, then product, shipment. So data models are classified into 4 types. One is relational data model, semi-structured data model, entity relational data model, then object based data model. So these are types of data models where we are having the data or the information images in various models. So these relational models are simply a model which can possess the data with relational identities. So semi-structured data model, where we can change the data then and there in the time of assembly, or when then there we can fix the photo in a pixel. Then entity relationship model, we have get the information, or we can choose the image based on the entity what we had. For example, I am working with the assembly line of one engine. I need some engine parts, piston, connecting rod, cylinder, crankshaft, like that. So based on the entity I have that model. Then object based data model, this object based data model is purely give the objects like square, rectangle, a circle defaultly in the system, then we can pick that model for our design. So all these data models are kept separately based on the application purposes. Nowadays the softwares were developed, so we have n number of applications in this area. So based on these applications we can develop more number of products, as well as we can produce a live image of a photo before we are going to the production. Then next, where some of the levels we discussed earlier here: conceptual level, logical level, physical level. So conceptual level is a design level, where I can speak the drawing in the form of design only. So I won't give the image, or I won't discuss the final product. For example, a Swift Maruti Suzuki Swift launched in the year 2026 means I can discuss about the conceptual model, how the design would be, how the door would be, what is the torque of that vehicle, what is the engine cubic capacity, how many shift pattern will be there. So all of the things I can discuss by means of concept only. Based on the earlier results, I can bring a conceptual design, or by means of a small sketch I can discuss. Then after that conceptual design is completed, in all the point of view, then it moves for logical discussion. The logical discussion, where what are all the things I will give in the form of illusion, all the things are we will discuss in the form of logically applicable for the business. Once the logical discussion is completed, it moves to the physical tables. So physical tables is nothing but where it comes for the desk for the discussion for the top level management members for taking final decision about the information given by the peoples or the employees who are working in that business. So most of this process of design to production stage will comes in these levels of data modeling. So in the data modeling, they will just simply put the image, or they will put the information in a single cloud. So while in the time of presentation, these informations are transferred via client servers. So client servers, they will collect all the information and it will easily display for the presentation. So this is the overview where how the levels of data modeling, how the data acquisition is happened in a graphical modeling system. The next topic is geometrical transformation. So geometrical transformation is nothing but where we can draw n number of components as well as n number of diagrams with various positions. The x-axis and the y-axis, z-axis. Okay, where I can draw the circle, I can draw the car, and what else, n number of products I can draw with the help of these computer applications. But this computer geometrical modeling is the mathematical representation of geometrical using software. How the software translates, or how the software transforms the 2D into 3D, or one dimensional into 2D. So the geometrical modeling contains descriptions about modeled objects, shape, and all other information. So this geometrical transformation plays very effective role in the analysis, especially in the area of finite element analysis, as well as we have go to the next level, we are using this system for computer aided drafting also. So this geometrical modeling transformation is one of the effective process where it can convert the orientation as well as size and shape of the object for the final image. So these things are stored in a cloud, so we can easily access these informations through a client server. Only internet, not intranet. Okay, so intranet we are using this one through only internet, not only internet. Okay, intranet we can using this one because these informations only roaming within the campus only. So outside the campus or with other side internet connectivity, we won't see this all type of information because they will look for the security. Then some of the techniques like translational, rotational, scaling and reflection. So these are some of the transformation techniques in the coordinate of our system. Then 3D transformation. 3D transformation is now it is one of the well developed as well as developing area in all the areas of engineering application. Is not limited to this or that. So this 3D transformation is the process of manipulating view of 3-dimensional of objects with the original position to the transformed position. So these things also contains these translational, scaling, rotational and shear reflection type of geometrical things. So these things are very, very important to define the physical attributes of the image in various dimensions. Then properties of 3D transformations, where we are having boundary representation as well as beat up. So boundary based representation, where we can have the surface of the 3D is represented with some end points or with some 4-point scale or with some 3-point scale. We can simply we can put 4 or 3 points. Within that 3 to 4 points we can draw a curve or we can draw a circle. What else possible we can draw? That is called boundary based representation. So bead up is a simple representation of boundary based one. So bead up is the next level of our boundary based transformation, where it has some polygonal structures and multiple parametric surfaces were also described here. So these bead up and boundary representations are commonly derived 3D transformation system, where we are having a translational like this, rotational, then this is reflection, this is enlargement. These are some of the 3D view of the object transformation happens in the 3D sectors. Then some of the mathematical calculation is also involved here. While we can see this diagram where the distance of x as well as distance of the y, where the object 1 and 2 were placed. Once in the time of translational, how much distance will vary, whether the distance are increased, obviously distance will change. Okay, as well as in the scaling, as well as in the reflection, as well as rotation. The rotational, it will purely discuss, we can see the angle of transformation. We can measure the angle of transformation very easily, as well as reflection. For the mirror image mapping of system, we can use reflection. Then enrollment, when we are having a enlarge the image size, it will vary the dimension. That also we can easily measure. So these mathematical formulas for this translation, where we can calculate using this simply move command in CAD system, as well as we can usually manually with the help of this matrix. P star is equal to matrix of x star comma y star. The x star is equal to x plus differentiation of x, as well as the y star is equal to y plus differentiation of y. We can simply substitute these x star and y stars in the P star. Finally we will get x plus dx, y plus dy in the matrix, as well as here x plus xy plus dx dy. So this is the translational matrix. So before the diagrams or before the image have certain location in the direction of x as well as in the axis of y. After translational, it will have some increasing the distance in the horizontally, as well as increasing the distance in vertical direction. The similar thing for the rotationals, where we are having the new position of the object at P star, where the new position of the x direction is x star and y star. Here on the rotational type, earlier we will discuss, we are having to calculate that angle. So angle in the sense, obviously we are having the trigonometric concept. So we can implement the trigonometrical concept of x as well as y, where the formula is x r cos alpha plus theta, as well as that another angle y star is equal to r sin alpha plus theta. So we can simply replace the values of x star and y star in the given matrix equation. Then finally we will got one matrix formula. So with the help of this matrix formula, we can simply substitute the values of r, then angle values, we will get the final thing. The next one is reflection. Reflection is also called as mirror. So these mirror commands we people are often using in all type of drawings in CAD, in CAD or SolidWorks or what else we can use this mirror command. They simply the same again, the change in position from x direction and y direction, notice x star and y star. So here the distance will be reduced, but for the aerial cases, while the object move for any of the transformation, the distance will be increased, but here reduced due to the mirror effect. So we can use that minus symbol before the matrix components. Okay, x or y. So then scaling is a form of translation which possesses two ideology here. One is a geometrical transformation as well as translational with some length breadth information. So both things we will get easily here. The change in position is p star, where we can in the x direction is sx, then the y direction sy. So we can have the final output in the d bar s is equal to s suffix x 0, s suffix with 0. So this is the matrix where we can frame using this scaling. Once we got the values or change in direction of x and y, we can simply substitute those values here, then we will get the final output. Then 2D and 3D transformation system, coordinate system. So already we are discussed many part as 2D and 3D. So 2D and 3D is one of the computer based coordinate storage system. Is very convenient to understood. Cartesian coordinate system is referred to world coordinate system, to WCS. So as well as when a picture is displayed in a display device, it is measured their dimension with the help of physical device coordinate, that is called PDCS, is corresponding to the display device. Depend upon the device it will changes. Then therefore the displaying of image of a picture, it involves some mapping of the coordinates, those coordinates where the image is to be displayed for the viewing purpose. That is called as viewing transformation. So these three components were world coordinate system, then physical device coordinate system, finally we will come for the viewing transformation. So viewing transformation is one of the final stage where we can exactly visualize the location of the image. So the world coordinates are be converted into finally the viewing coordinate. So it's a step-by-step process. Initially the world coordinates are converted into PDCS, then PDCS are converted into visual transformation. So this step-by-step process, it will changes its position, and finally we can see the final image here. So the converting of world coordinates to physical coordinate, the normalizing the viewing coordinate, then the converting of that normalized viewing coordinates to the device for the final visualization. This is the main information where we can get from the 2D and 3D transformation, because where we simply visualize the image in a display is not the output. So it is a step-by-step process where it can update further, and it will give it will work out with some software increment of the pixels or decrement of the display will adjust based on the specification it has, and it will show the final image. So that is the simple thing. Here the steps involved in the viewing transformation. First we can fix the image in a world coordinate, then we will get the primitive attribute, then based on that attribute we can locate the viewing coordinates. After that viewing coordinate, that world coordinate, that viewing coordinate is converted into normal coordinate like a map viewing coordinates. It will exactly locate the x and y position of the system. Then finally click all the parts of pictures which is lie outside the viewport. So viewport is nothing but where we can see this image, this is clipping window, this is world coordinate, this is viewport. The viewport is the port where exactly we can see the image directly, as well as it will lies direct to our eyes. That is called viewport. So viewport normally we are having very high quality empty or very closely packed pixels. This condition is only applicable for our raster coordinate system for CRT tubes only, not for nowadays available LED tubes. But nowadays available LED system, LED light based display system doesn't have this kind of application purposes. That light emitting diode has its own application where we apply this kind of informations there by means of waves. But this type of transformation we can observe this view and world coordinates where it have XW minimum, then XW max, then YW minimum, YW max. So this minimum and max is the starting point of this A, this is B, this is C and D means. So where the minimums are A, the maximums are B for the both in the horizontal and vertical direction. This pixel will this square will move up. So based on the intensity of the image, these pixels are adjust themselves. So then finally, where we are having the viewport is very clear. So this is the way where we can get very clear image. But this clear image is only centrally focused thing where we can see the image direct to the eyes. It is obviously a very good clarified image that is called viewport. So this is the a line sketch where it simply discussed about the X-min and X-max, as well as where we are having this Y is V, where XV min then XV max. So similarly we are having for Y direction YW max as well as YW minimum, YV max, YW minimum. So based on the location of this starting A pixel and B pixel, we can simply categorize the location of our images with different areas. Okay. Then clipping is a point where very easy to given window is very easy, where we can figure out the exact image in a form of rectangular indicating window. So the point where clipping tells us is where within the given window or not, it will decide whether the minimum maximum coordinate. So only clipping will give the informations of creating minimum and maximum coordinate of the system. So based on the clipping we can fix the image information. So this clipping is classified into three types. One is line clipping, coherence torrent clipping, as well as the coordinate region clipping. So the line clipping is where we can have the images in the same lines only, where we can draw a simply horizontal vertical lines in a plane. Then coherence torrent clipping is where we can draw the images with the help of some algorithm, as well as clipping region, the simple diagram where what we can see this XW and YW, X max and Y max. This is called as clipping window. You can see this one. So this is clipping window where we are having that lines which is located inside the square rectangular box, as well as in the outside the rectangular box based on the images. So then this is the step-by-step algorithm, where this step-by-step algorithm where we have step 1 we need to assign a region of endpoints. In step 2 we have provide a code for this certain line, where here clearly they will mention number 1 is top, 0 is bottom, right is 0 is right, then left is 1. So we can simply fix 1 1 1 1 1, then 0 0 0 in centers. So we can, based on the movement of the point, we will provide 0 0 1 or something else. So this is a simple algorithm where it's derived to fix that clipping concept. So similarly, where we are having the AND operations here, so we just simply do the multiplication of points what we gather for fixing the end points. So in that to get the intersection of point where window boundary region codes, so everything is object update based on the region. So based on the regions where we are having a multiple objects as well as multiple objectives in the system of algorithm where we are developing for the clipping concepts. Okay. Then mathematics of projection. Mathematics of projection were nothing but where we can have very good mathematical behind the drawing. Without mathematical thinking we won't get the output of the drawing. So these mathematical projections are a very essential thing to develop 2D and 3D graphical systems entirely. So these 2-dimensional and 3-dimensional graphical systems is completely involved with some mathematical formulas. Basically it works under. So nowadays we are having softwares, but in earlier days people they are having algorithms as well as step-by-step procedure for showing their intention here. So many 3D CAD CAM packages such as AutoCAD, SolidWorks, CATIA, Rhinoceros, they are working with multiple projections like dimetric, trimetric, oblique, planometric with 1 or 2 point perspective. So all these things are involved in this type of packages. So all these packages are admittedly toward the direct projections to see in the 3D view of the object. So here this image where we are having steps. This steps is a 3D image where these steps located in the 3 directions, x, y, z, where with multiple planes, horizontal plane as well as in the vertical plane it will locate. Now I am going to rotate this image. Once I rotate this image, the position of the image is going to be changed, number 1. Then point number 2 is the coordinates of the image is going to change. Then point number 3 is where the image dimension is also going to change. So everything is changed once the image move for the next level, or I do some operations, or I will do some applications. Plane X plane to Y plane to Z plane. So likewise it will move further. Okay. Now listen here. So this geometrical model we are having a rectangular cube as well as a square cube, which is located inside a square box with various angular dimension as well as direction x, y, z as well as angle alpha, beta. So these alpha, beta we are having, we can take a trigonometrical concept. Obviously the involvement of that angle is there, alpha, beta, obviously we are moved to a trigonometrical law. We can use that law, x is equal to r cos theta and y is equal to r sin theta. Then simply we can apply this x values, y values in the further transformation. That means before transformation and after transformation. When we are doing some differentiation, we will get some equation. So whenever we are having this geometrical transformation with the help of mathematical projections, we are having the involvement of angle. Simply we can use these mathematical formulas and we will apply the values of x and y, z as well as alpha and beta. We will get the answer. This is the simple application of this mathematical projection. However, we are using the software. The software is also doing the same. These softwares is also with the help of these mathematical principles they will do the transformation. We can easily study the transcripts. Once we are having right internal resources, internal sources of the programming, we can simply read out the program of an AutoCAD. It clearly defines, they clearly defines all these informations in there. Okay. Then hidden surface detection algorithm. So hidden surface design algorithm, where we can use this conversation resembles the 2D system of drawing. So in the 2D system of drawing, where the hidden surface detection algorithm helps to identify the hidden lines, because the hidden lines are the lines which is necessary in the time of geometrical transformation, but while viewing the object those lines are not necessary. So once we can view that object, those things are not necessary. So this hidden surface detection algorithm, this is classified into 2 types. One is object based methods, another one is image based methods. So these object based methods and image based methods are widely used in the development of hidden surface detection. So this object space method is nothing but where various parts or objects are compared with various visible models such as wireframe model as well as some visible lines. These lines only we can see the parts in the form of lines. This is the speciality of these drawings as well as some colors. Okay, some colors may be same or different. Then next one is image space method. Image space method where the various pixels are determined in the visible surface instead of visible line. Each points are decided in the visibility of product in any part of visible line. So then the pixel is on, otherwise off. So maybe the variation of the pixels determination we are doesn't get the very clarity image of that
output. So these methods are very visible surface determination, as well as these methods are computer requiring long processing and time. The power consumptions are very more. These are some of the differentiations in image space method as well as object space method. So the object space method is one of the optimized tool where we can see all of the images clearly, especially the line scale. So whenever we are moved for the translation or some different combination where we are having some object based system. So this object based system where it obviously it will produce the hidden lines. So these hidden lines are a very good objective for a translation receiving point. Once the translation receiving point is the point where we are going to see the earlier position of the coordinates, or simply the earlier position of the earlier direction or earlier dimension of the coordinates, where the x is fixed, where the y is fixed, what is the dimension of the x, what is the dimension of the y. Then similarly all the angular details, everything is going to be noted. Only we have that some reference. So that reference line is called hidden line. So when the object is transformed or when the object is completely developed, then that point is that hidden line is not necessary. So that hidden line is not necessary in the sense, once we are going for the final drawing, once the hidden line is available, it will reflect in the final product, but we don't want that hidden line. So we need to delete the hidden line. So hidden line deletion algorithm is a methodology, is available in all the type of coding system where people they are having these codes defaultly while we are seeing the final image. So this hidden surface detection algorithm provides a very useful information as well as a very good scene for the 3D image in various shapes and sizes. So this hidden line algorithm is mainly focused to identify the final image, as well as we don't want to have this unnecessary lines is also in the hidden environment. So this object space method is one of the effective method in the hidden line algorithm to generally to identify the previous position or previous location of the system, as well as where the method it will determine the object for the final drawing with various colors. So image space method is also same, but this point of visibility is very lower in the image space method, but in the object space method the point of visibility is very higher. As well as in the image space method now we are processing higher level images with more amount of quality. The viewers also required very huge amount of quality. Those type of systems they are preferred is visible surface determination in the image space method. So these two things are very essential in the viewing of image. So these are some of the topics where I want to share in this video. So this geometrical graphical system in a computer graphics in a CAD, it's a simple, it's not a graphical output where we are having these graphics. The background workout of these graphics is very complicated for getting the output of the image in the form of 2-dimensional as well as the image in the form of 3-dimensional, because this process is very tedious process in earlier days in the form of computer graphics. What are the things we are discussed here as the roster graphic system as well as vector graphic system. All the computer graphical systems are earlier computer graphic system where in the time of 1970s where the world starting the era of graphics and implementation of graphics in various areas such as production and filmmaking. So this user interface and everything are very common nowadays. We are having very fine user interface while we are taking AutoCAD. We are moved up to design 2D and 3D where we are moved discuss about CAD. We can do the design 2D 3D as well as we are do the analysis with the help of the ANSYS. So all the things are happened nowadays with the help of the single software. So this single software designation as well as the single software design is nowadays a very good approach for all the industrial people as well as entertainment people who are develop their views in the form of reality. So I will close this session. Thank you for the opportunity. You will any doubt you can